Hello, everyone. Yeah, thank you for coming here today so that we discuss networking. As you can see on the screen, today we'll be discussing the first part of networking, and the main content would be focused on discussing some particular concepts of networking. We will also discuss the difference between public and private networking, and it will also try to explain what is a private network. So as we go along the way, if you have any questions, please just bring them up, and yeah, I would do my best to answer them. Okay, so let's start with what is network? What is network? So a network can be defined as a set of connected devices, or in our particular case, could be computers, and they are connected in such a way that they can exchange data and share resources across with each other. So as you can see from the diagram, you could have a laptop, a table computer, smartphone, all being connected with each other through a wireless point, access point, and and while also you could see like an email server, a terminal client of another computer, a printer, an IP telephone connected with each other through a hub. And this you could consider this one section, the section where you have smartphone and a laptop and a tablet computer connected with each other as a network between those devices. And on the other side, you could also have you could also see the email server section, printer, and IP telephone as another network between those devices. And so networks can also be connected with each other to have what is called an interconnected connection of networks, or what we popularly refer to today as internet. So what does it require for this setup to work? I mean, these devices are connected with each other. It could be a wireless connection. It could be through cables. So our main interest today would be to discuss what are the necessary requirements, what are some properties or aspects that are needed for such an interconnection of networks to be successful or to be usable to those using these devices. So the first concept that we are going to discuss the first concept that we are going to discuss about networks would be IP addresses. So in order for networks, as we have seen in the previous diagram, to actually work, every device in the network have to be given what is called an IP address, or an Internet Protocol address in full. So what does this address do? It helps to specify the location and identity of the device. I will talk later about how this is understood by every device in the network. So and now, so there are two types of IP addresses that exist. We have an IP version 4 address, and we also have what is called IP version 6 address. So what is particular about these type of IP addresses? So in an IP version 4 address, you have 32 bits integers. So it's most commonly written in this notation, where you have where you have the value of 4 values separated by dots, as you can see in the example. The notation is referred to as a dotted quad notation or a dotted decimal notation, because these are decimal, the x, the x. Can you hear me? Some noise is coming up. Hello.
Yeah, we can hear you too. Go ahead, please.
Okay. So I was saying that the format for writing IP address, the commonly accepted format today, is known as the dotted decimal notation, where the 32-bit bit is separated into groups of 4, each of 8 bits, as you can see in the example. So each group is made up of 8 bits, and you can now convert these 8 bits into the equivalent of the decimal of the decimal, which means that the decimal value for each of these x that noted up here can only be a number between 0 and 255. And so each section is independent of the other. So, and in total, the 4 different 8 bits make up 32 bits, or you could see it as 4 bytes. Okay. Yeah. Okay. So now let's also see an example of an IP version 6 address. So maybe another question that you would ask is, we're wondering is, why do we have 2 versions of addresses? So in the early days when of the internet, we started using this IP version 4, and it was okay because the number of addresses that can be generated with this formatting were enough for what was foreseen at the time. So it worked well. But as time goes on, the number of devices that were being connected to the network or to the internet started growing enormously, so much that it became evident that IP version 4 would not be able to provide enough IP addresses to support all the devices that were being connected to the internet. So that's why it was decided that a new type of IP version or a new method of addressing should be created. So a method of giving address or assigning addresses for the devices on the internet should be created, and that came up with IP version 6. So it is almost similar as the IP version 4, but instead of having just 4 groups of binary numbers, you have 8 groups of 4 hexadecimal digits. So as you can see from the example, the first group 1, is made up of 2001. The second group is of 0DF8, and so on, with the last group being the 8th group being 0F11. Each group, unlike in the binary case where we had each group separated by a dot, in the IP version 4 case where we had each group separated by a dot, we have the groups in the IP version 6, they are separated by columns, as you can see also in the example that is shown. Now, there's an extra thing that comes with IP version 6 is that, of course, since there are 4 hexadecimal, each group represents 16 bits. So hexadecimal is matches this number of bits. So since the extra thing that comes together with IP version 6, is that when you have a case where there are repeated zeros, like there are zeros in the group, you can replace that section by just writing a column there. However, you cannot do that twice because it then becomes unclear where how many zeros or how many group of zeros were in each location. So, for example, if you did this, if you replace here the zero in the fourth, the zeros in the fourth and fifth group by a single column, and you also replace the zeros in the seventh group by another column, it might become unclear whether it was 1 0 in this column and one set of zeros in the gap below between 3 and 6, group 3 and 6, y and 2 at between 6 and 8, or it was as it's shown here where you have 2 in 2 gaps, set of zeros between group 3 and 6. So usually you just replace one section, and the other wherever zeros occur in the other section, you leave as it is. Okay. So okay, now that we have discussed about addresses and all of and the aspects of yes.
Please, will it be a technical fault if I don't replace the double series of zeros with columns?
No, it's just easier to name it without the zeros by replacing it with columns. It's not that it's required. It's just a,
so it's for convenience.
Exactly, for convenience.
Okay, thank you.
Yeah. So we have seen how devices in the network are given identities, or you could say how they are identified by some form of some addressing scheme. Now there's another concept of in the network called subnets. A subnet, you could see it also as a logical subdivision of the network. So instead of continuously adding devices into one network and making it grow extensively, you could decide to say you create within a network a subnet for a particular set of devices, and then another subnet for a particular set of devices or services, as maybe for those who are familiar with some of the topics that we'll see later in AWS. But yeah, so the result of this set subdivision would mean that within your network, you could have subnet, you could have IP addresses that go to a particular subnet, and another set of IP addresses going to a particular subnet. So if you have maybe an incoming request, I go back to the previous diagram. If you have maybe an incoming request, say, and you want to decide now for which network does it go, or do you send a request to all of these devices, and the one that has the corresponding address will now be able to consume the message and say, yes, this message is for me? Or do you decide that, oh, the address on the IP on the message is for a device on this side, on one side of the network, and not on the other side of the network? So when we divide the network into this kind of logical subdivisions called subnets, what happens is that now your IP address, which you initially had just like, for example, 172.1.6 and 1 then .0, becomes a little more, there's a little more to it, how to interpret it, and not just as the simple identity of a host or a device in the network. For example, after you have splitted your network or divided the network into subnets, we now have what is called a subnet mask. A subnet mask now is used to identify which network or which subnet an IP address is coming from. So, and therefore, how does this happen? So the subnet mask, for example, 255.255.0.0 represent, or equivalently, as we will see later, can also be written as /16. I would explain later where the /16 comes from. But consider the subnet mask 255.255.0.0. It indicates that the first 16 bits of the network of the IP address are the network part of the IP. So this points every device points to devices in that network, and then the host, the particular device in that network, will be identified by the remaining part of the IP address. So in this case, of course, the complete IP address is the identity of the host, but to know which subnet the host is located in, you need the first 16 bits of the IP address. I don't. This is blocking. Okay, so as you can see in the example, the first 16 bits down here, behind on the gray part, is called the network portion, and then you also have the second 16 bits are the host portion. So every device in this network would have the same values for the would have 172 and 160, no, 172 and 16 as the first part of the IP, and then the remainder of the bits will be unique for each device in that subnet. Now, this value, the subnet mask, also would be able to tell devices that are not in this subnet that if they want to communicate with a particular device, they would be able to tell that this is the network part of the this network part of the IP would identify which network that device that they need to communicate with is located in. So if you have a device that is not within the network, it can first start by routing its request to the network where the device is in, and within that network, then the device can be located by following the subsequent parts of the IP address. So if somebody has a question, I know this is also a very technical aspect. You could raise the question now. Okay, if not any, I will continue. Yeah.
Hello?
Yeah. Yes.
Yeah, good morning, sir.
Good morning, Sally.
Yeah, okay. I just put the question in the chat there, but I wanted to find out why is it that the IPv6 is not used in other countries, like in Europe.
Yeah.
We are using IPv4. So why is it not used? Because I understand you said that IPv6 came up because the nodes, I mean the devices could not carry. That is why. So why is it that it's not used in Europe and other countries?
So yeah, I mean IPv6 came up because the number of devices that were getting connected to the internet were growing in number. So it was IPv4 could not support that. I mean, the number of devices were growing and would maybe exceed the number of addresses that IPv4 can provide. Now, about your question of why it is not used in some countries, the fact is that many organizations are still using IP version 4 because it is still enough for their needs. But overall, the internet is gradually shifting towards IPv6 because in the long run, IPv4 would not be enough for the purposes of for connecting to the internet. Like there will be more devices than IPv4 can support. So it's not that it's not used in certain countries, it's just a few organizations are able to support it yet and see it as a need for them now, because it's not yet that a big, IPv4 is not yet totally insufficient, but it is foreseen that in the long run, it will not be able to support all devices in the internet.
Okay.
Yeah.
Yeah.
Okay. Okay, so let's jump into different classes of IP addresses. Okay. So before, again, going back in time, IP addresses were grouped into different classes. You could, so this way of classification of IP addresses was used in 1981 to 1993, where you had what is called Class A addresses, being addresses that started from 1.0.0.0 to 126.255.255.255. And the default subnet mask in such group. Please, can someone mute? I cannot hear you. If you
Continue, Tim.
yeah. Okay. So and then also so all IP addresses that where the first bits were from 00 to 011, that is at least up to eight possible IP addresses in the eight possible numbers at the very beginning were classified as Class A, and you would have the IP address ranging from 1.0.0.0 to 126.255.255.255. The default subnet mask in such a case was usually was assumed to be 255.0.0.0.0. You'll also see and from time to time hear about Class B IP addresses with this range as shown on the screen. And also the default subnet mask was 255.255.0.0. And similarly for Class C. But Class D and Class E did not have any default subnet mask. Class D was used mainly when you wanted to do what is called multicasting, that is sending a request to multiple devices at the same time. And Class E was mainly for experimental purposes. Another thing, this is no more useful. This classification is no more being used today. I mean, it's you would hear it from time to time in discussions, but it's not as relevant because It has been replaced by what is now called classless interdomain routing. So this is also a method for allocating IP addresses and for IP routing, which was introduced in 1993 to replace what we just saw, the classful network address architecture. In this classless interdomain routing, or CIDR, it is often read CIDR. You have this new structure where instead of writing an IP address and its subnet mask as, for example, 172.1.16.1.0 and the subnet mask as 255.255.0.0, you now use this format instead, which is like 172.16.1.0/16. So the same thing, but represented in a different way. And also, unlike before where you had classes, people had to remember the class to tell what range the IP address is belong to. Yes, the cyber notation clearly just says all IP addresses that starts with this format, that is the first 16 bits, for example, representing the network part of the IP address, and the second 16 bits starting from starting from 1.0 up to all the bits are consumed is IP addresses in this CIDR range. So 172.16.1.0/16 is called a CIDR block, i.e. a set of IP addresses. Yes, somebody is asking, does the 16 represent 255.255.0.0? Yes. The answer is yes, Edwin. Okay, so that's why in the previous case we had this image where it was already shown here that the subnet mask is 16 instead of writing it out as 255.255.0.0. Yeah, and you still have the IP addresses written in the same way, the dotted decimal notation. Okay, so another thing that we want to consider is maybe the different types of IP addresses. The two types of IP addresses called static and dynamic IP addresses. Oh, okay, that's a mistype. The first sentence, take the groups are separated by columns. So static addresses, so this, as the name implies, are addresses that do not change by themselves, or it's not done automatically by the network or the system issuing. There's no such thing as the system issuing IP addresses in this case. So you are the one who assign the IP address to the device in the network, and it does not change by itself. You are you as maybe the network administrator are the one who would change this, who can change this static IP address. Now, since you also are the one assigning this IP address, care must be taken that you do not assign to two devices the same static IP address, because it would it could result in issues where maybe the communication is not working properly because message sent are being delivered elsewhere, or there's conflict of in the network because of two IP addresses colliding. Now, the other type of IP address in terms of who or how they are assigned is called dynamic IP addresses. or dynamic addresses. So these are IP addresses that can change over time. Usually, this does not happen so very frequently. So the fact that they say they change over time is not like they will change anytime. It's just to mean the service which provides these IP addresses does not issue this IP address forever. Like it does not assign this IP address as a permanent IP address. This service called Dynamic Host Configuration Protocol. It's a service that could be running on your network, maybe on your router or on a dedicated server. So for each device that gets connected to this network where this dynamic host DHCP protocol is running, the DHCP protocol immediately identifies that there's a new device connected to the network, and it issues this device an IP address. However, this IP address is not issued like a permanent one. It's only kind of a leasing, which means that after it's only valid for a limited time, and after which after that time a request for a new IP address must be made so by the device. And therefore it could happen that even after you've made the request for a new IP address, the DHCP service issues you the same IP address, but it could also happen that it changes the IP address. So that's why it's called dynamic IP address. And the service is the one is in charge of making sure that no two devices have the same IP address. So yeah, and so when the time or the active time for your IP address in this kind of situation is over, then you get a new IP address. This is also very common in organization where you get there and you plug in your computer to a network, and at the end of the day you unplug your computer and you get out. So the IP address that you were using while being on that network is not permanently yours. Maybe after you leave, it will be given to another person, or while you're there, it could also be taken and given to somebody else, and you are given this another one, as depending on how long this time this IP can be valid according to the DHCP service. So there's another question in the chat. Is it possible to know the validity period for the IP address so that you shouldn't be taken unaware? Yes, it's possible to know the validity period for the IP address. In fact, it is configured by the network administrator who set up this network and configured this DHCP protocol. So, but as a user, you don't have to worry about this IP address changing. Your device, your operating system takes care of this. So there's a network service also running on every operating system, be it Windows, Mac, or whatever Linux that you are using, operating system that you are using. Whenever this is happening, this operating system automatically in the background requests the DHCP service for a new IP address. Thank you, Napoleon. Is that clearer for you?
Yeah, it's clear. Thank you.
Okay, thank you. So, yeah. So now that we've talked about, IP addresses, we've talked about static IP addresses and dynamic IP addresses. And the whole point of the discussion has been to understand how in a network devices are identified, how do they get these identities, or how are they issued these identities? And so we've come to know a little more about IP addresses, just like just like we know about our home addresses. So now the question still remains that what happens when a device in the network then wants to talk to the other? What are the rules? What is the standard of communication, or how is the communication transmitted from one device to the other? For example, we could look at the analogy of in our human case, where living in one house and sending a message to the other, to another house. It could be carried by plane, by car, or by somebody going on a bicycle, or by ship, or it could be a package. And depending on the size, also it would affect how it is transported or taken from one origin to the destination. Is it going to be taken in parts and then reassembled at the destination, or is it going to be taken in full and just delivered at the destination? By what means of transport would your package or your mail, for example, be sent? Maybe if you want it fast, also you could pay for a higher service, a faster service. Then it could be also taken faster to the destination. So just as in that case, computers also need to be able to decide what means of communication they need for the particular purpose that they want, for the particular information or data they want to send to each other. So we've already seen how they would identify identify each other on the network by using IP addresses, which is in our analogy equivalent to our home addresses. So let's find out what communication protocols are there between devices in a network. But before we go to that, of course, we need to just mention, of course, that every protocol must therefore specify how the data will be packaged. So will it be in envelopes like we have in our case? What rules are there to be followed in when sending requests to sending packages from one system to the other? How are the address, the content of the package to be treated or read? So, at what rate should the package be delivered, or in what way should they be delivered? All together, or in fractions, in parts, and then reassembled at the destination? So each communication protocol must also specify all of this. And if there are mistakes, how are they going to be corrected? This is also very important for computer systems because mistakes are very likely. And so, yeah. So, but also the main communication protocols and computer systems used today that we are interested in the transmission control protocol, which is also known as TCP, and the user datagram protocol. So just some brief description about them. So TCP, or as I said, transmission control protocol, is kind of a connection-oriented protocol. So it means that for this to work, the origin computer and the destination computer need to establish a connection before they can communicate. This it's more or less, let's say you want to make a phone call, for example, then in order to talk with the person on the other end, you have to wait until a connection is established between your phone device and the phone device of the other person. Then the two of you can communicate. So in this case, it is connection oriented. Your communication is connection oriented. And so, and also TCP support error detection by some other mechanisms. We will not dig into that, but because it tries to support this error correction, it now has a lot of latency, because it tries to make sure that, try to fix problems and to make sure that things in the communication protocol are delivered properly. You often use TCP in text communication, WhatsApp, iMessages, and HTTP. So the order in which packages were sent or messages were sent has to be maintained in TCP. But UDP, User Datagram Protocol, is connectionless communication. It's a connectionless communication model. So in this case, it doesn't first devices that use UDP don't need to first establish communication with each other. They more or less just say, okay, I have this package over the network and it needs to be delivered to this person. They are not interested in trying to make to fix errors or make sure that the package is delivered. It's more or less passing it onto the network with the address, and there's no back checking whether the package was really delivered. So for this reason, UDP tends to be faster, but has no, but as I said, has no guarantee of delivery, no ordering, no duplicate protection. So another mechanism to make sure that the UDP really works is that instead of just sending one package, which could get lost on the way, they send it several times. And then some mechanisms are used by the application communicating in this style to resolve duplicates and to try to fix errors. So it uses what is called checksums to try to fix errors. But UDP itself as a communication protocol does not take care of these things. It just tries to make sure that what is given, provided it by one system device in the network, it does its best to transmit it to the destination device. You can see this often in video games, video communication, and voice over IPs. This might be a little over the head how this works, but maybe when we go further in networking at the higher level, we'll dig deeper into the mechanisms behind TCP and UDP. Yeah. So, okay. So now,
Yes, sir.
yes.
Please, I just wanted to clear some doubts that I've been having. Oftentimes when I receive messages, maybe from social media platforms like this, Telegram or WhatsApp,
Yes.
I have in my laptop or my tablet and phone, the messages usually come first to my laptop before my phone. So I was wondering, what is the problem? Could it be an IP related to communication protocol based kind of problem? Or why should it come to my computer first before my phone?
Your device, your phone could be using what is called a push mechanism. So when messages are received by the server that is handling, that is supporting, say, Telegram in the back end, then they are pushed to your phone. Push here means that they are sent to your phone. but it could happen that the messages are arriving the server at a time when it just did a push. It just checked whether they were messages for you, and it did a push. Then it has to wait for some time before doing another push, so that it doesn't always it doesn't exhaust itself, always checking for messages. On the other hand, your computer could be doing a pull mechanism where it keeps checking for messages in the server, and as soon as a message arrives, it identifies that the message is there and it pulls it to your computer. So your laptop gets the message as soon as it is in the server from wherever it was sent. So this is just one scenario on how Telegram might have implemented the solution to deliver messages both to your phone and to your laptop. But it's not really about these communication protocols that are being used. What has already happened between what is now happening? So if it's the push mechanism, maybe a Telegram server package a message and sends it to you over TCP. Yes, they would use TCP, but the reason for one coming before the other is not based on whether they are using TCP or not using TCP. You're muted.
I was just asking because I just caught TCP or communication protocols and IP, because in your example where you were showing us the various types of how IP here, where you said you could send information either through some is taken by maybe a means of transportation like car, bicycle and ship. You know, these various means of transport are different in terms of speed and delivery.
Yes.
So I was thinking that maybe sending a message like that, maybe the one that comes to my computer maybe uses a car, and the one that comes to my phone uses a bicycle or something. That's why I was asking.
Okay, maybe that's something I also left out in this case of the analogy for humans communication. They can choose at the point of sending what kind of transport means they would use, but for computers, they are designed so again, as I go further, you would realize the applications in the computer are the one actually sending the message, sending communication with. It's not just the devices. So every application is designed to use a particular communication protocol. It's not like they switch between one and the other from time to time.
So the IP addresses for both phones and computer are the same, right?
No, your IP address for your laptop is different from your phone. It cannot be the same. They have to be unique. But the software or the program that is communicating with your phone and the program that is communicating with your laptop are probably different, or even if they are the same, they could be using a different communication protocol. But it would always be, if they are using TCP, they will always use TCP. They don't switch from TCP to UDP from time to time, depending on choice. The program, it's like also when you browse the internet, you are always going over HTTP, which is based on TCP, but you don't switch on one day and say, no, HTTP is not more fast, I want to go to another means. So you could imagine this as a situation where you are in a you are born and you subscribe to one particular method of delivery, either by air or by land or by ship. So you don't change over time. So yes, but because of the kind of method of sending it, one could be faster than the other. Yes.
All right. Thank you.
Yeah, and it could also be less reliable depending on how it is implemented. Okay. Okay, I hope I didn't miss any other question. Okay, so we were talking about these communication protocols, and now let's look at IPs, sockets, and ports. So I just also pointed out in answering Napoleon's question that in reality, it is not just the devices that are talking, it is the applications within the devices that are talking with other applications and other devices over the network. So it's like the question of if a package arrives in a particular home, who receives the package? If a package is leaving a particular home, who has sent that package? So just like our addresses on envelopes also bear the name of the person in the home who is getting the envelope, IP addresses are just identifying the computer or the device, to be more generic, that is going to receive this message, and therefore the particular application within this device that is going to execute this message, that is going to take care of this message, or that the message is meant for, is identified by using what is called sockets and ports. So what is a socket? A socket is like a process that is used for sending and receiving this data over the network. And so it's like the endpoint of the application for within the computer for a two-way communication with another computer in another, with another program in another computer. So a socket is usually bound to a port so that during, say, TCP communication, the application for which the data is destined can be easily identified by using ports. So what is a port? A port is just a 16-bit integer that is assigned uniquely identify applications or services running within a device. Usually the port number goes from 0 to 65535. So I go now to show you another this example. So for example, now you have this IP and in green, and you have the port 80 bound to it. Port 80 is usually for HTTP communication. So any request that is coming with this IP and is labeled with this port will be sent to the service within the server that is in charge of handling requests coming through port 80. So even if you say, for example, you run a server on your computer, it usually has it is usually running listening to port 80 for requests coming to it, just like you have other ports or other services running on the same computer. And the operating system on the computer is in charge of forwarding network requests to the right application, and also taking packets from the application and forwarding them to the network to be sent to the right device, and also the device operating system would okay. But I guess you are already answering the question from the Telegram group. Okay, sending, so the device, so with these port numbers, we can identify specific services running within a computer that will be used to process a request coming from the external, from the network. So now we see that port numbers are added to IP addresses, just as we add individual names of members in a house to identify who or to what service an incoming request is meant for. So I just give you an example of some port numbers. There are a lot more. So port 80 is meant for Hypertext Transfer Protocol, or HTTP. So usually this is the main protocol that most of us interact with. HTTPS, which is a secure version of HTTP, it uses port 443. SSH, which is meant for interconnecting from one computer to the owner or to the other via a shell. It's using port 22. Remote desktop protocol uses port 3389. So those who have used one Windows machine to access another Windows machine would have used port 3389. And for those of us that have already come across DNS Route 53 in AWS, now you can see why it's called Route 53, because as a domain name service system, it uses port 53 for communication. And also anyone who has used a mail, you know that, I mean, not that you know, but now it's shown, we can see here that the mail service uses port 25. So these are dedicated ports for these particular services. The new services come up every day and they might get dedicated ports. Others just get ports that are used temporarily and then are released for other services. Yeah. So let's look at what is public and private network. So public network is one where anyone can access it. There are no security constraints or rules or access protocols to where you have to maybe log in, for example. So for example, if you go to an airport and you find an internet endpoint where you don't have to provide maybe some details to be given, some password, then that's more or less a public network. You can have access, you connect to it to be able to access the internet, for example. In contrast, we have what is called private networks, which have restrictions and access rules, and mostly only allow a particular set of people to have access the network. In terms of infrastructure and hardware, there's no difference between public and private network, but issuing addresses for public network, you have, as we said again, since it's global and these network IP addresses have to be unique, it requires more care than when you are trying to provide IP addresses for a private network, because they can be automatically generated since you are in control of the whole private network. So what's the difference between a public IP address now and a private IP address? Private IP addresses, again, cannot be routed over the internet. And so you cannot reach a private IP address from the internet, because it's, of course, you're even prevented from reaching that network, into that network or devices within that network. And as I said, they can be automatically generated, and generally they are free, but they are unique only within that network, but not unique globally. For public IP addresses, you have IP addresses that are used on these are IP addresses that you use on the internet. So most of us, all of us that are connected now over the internet to listen to the Zoom call or to participate to this Zoom call, we are all using public IP addresses to connect to each other. Traffic from them, of course, yes, can be routed over the internet. They are not free. They are issued to you by the internet service provider that you are using. And of course, they can be used for both private and public network, but it makes no sense to have a public IP, to use public IP addresses for private communications. So, because of course you pay for them also. So, rather, public addresses, IP addresses are mainly used for public networks. So on the other hand, the question now we may ask is how do computers in a private network communicate with each other, or with computers in maybe another private network that is not in the immediate vicinity, or that is not in the same private network. So there's what is called a virtual private network. So VPN, it helps to extend the private network over the public network or internet, thereby enabling devices to send and receive data across public network as if they were connected to the private network. So this VPN creates some kind of secure tunnel between your device and devices in between devices in a private network and a device which maybe might be in the public network, like in the internet, and now allows this communication by so doing, it allows communication between this the device in the private network, the devices in the private network and the device in the public network, but in a secure manner. So there's no chance for maybe data leakage or maybe some man-in-the-middle attacks, for example. The main point here is that from the user's perspective, from the person who is in the internet or in a remote location connecting to the private network, he is able to attend to it as if it were as if it were he were directly connected to this private network. Okay. So a VPN encrypts your connection. And so what is meant by encrypts your connection? So what it does is that for every package that you are sending through this tunnel that it has created, it takes it and the data within it is scrambled in such a way that it becomes unintelligible. You cannot read it or understand it. A human or another computer without first decrypting it. That is the opposite of encryption, making it intelligible. And to be able to decrypt it, you have to have what is called the encryption key, or in some cases, the decryption key being different from the encryption key. You have to have understood how it was encrypted and have the required keys to be able to decrypt the data. So if the data you are sending over for internet to a private network is intercepted, it will not still be meaningful to the person or attacker who has intercepted the data. It's simple. So I just give an example of a simple encryption. Simple encryption here is that one that has converted some English sentence into this, what I show here on the screen. So of course we cannot read this; it doesn't make sense to us. And the only way to know what this means is to be able to reverse this encryption into what it and be able to find out what was there originally. The way your data is encrypted or scrambled is called a cipher. And for every such cipher, there's a key or logic that allows one to be able to decrypt or reverse the encryption of the message so that it makes sense again. So again, so to keep your communication safe, then you also must therefore guard your key and logic of encryption very carefully. In our example, the key logic was a very simple one. To decrypt it, we just replace the characters with the previous character in the English alphabet. So you can see that I replaced the J with an I, the B with an A, M with an N, X with W, and so forth. And I am WirfonCloud. So this message was what was encrypted, and the approach to decrypt it, the encryption approach was just to replace the characters with the next character, and therefore the decryption approach would be to replace the character in the encrypted message with the previous character. That's a very simple encryption logic, but nowadays we have very strong encryption mechanisms that we use, and in order to, and the keys are also very long or very big. It's not also that, so it's not very easy to decrypt such mechanism. An example of a very popular one is Advanced Encryption Standard, AES 256-bit. We'll hear about this more often as we go on in our cloud journey. So how does a VPN work? We often, so when we browse the internet, we often give away our real IP addresses, browsing history, operating system information, and many other things about the devices that we use to browse the internet. But in order to restrict this, and to hide this identity from maybe the public, what a VPN does is that it assigns to you a new IP address, first of all. Then it also would reroute your traffic or your internet connection through a server in its own network. So a VPN has its own network first, and at that point, and all of that is done while also encrypting the data that you are sending. Now, before your data information now is being forwarded to whatever device you wanted to forward it to, it's now being sent from the VPN with a new IP address. That is the anonymous IP address that was given to you. And therefore, the receiving party sees a different IP address. And any individual or any body intercepting the request would also see that this anonymous IP address. And so they cannot tell exactly who is sending, because every time you make a request, maybe your VPN would change your anonymous IP address from time to time. And also for VPNs that support encryption, they also encrypt your data and therefore make sure that even an attacker or intercepting the data or the request would not be able to make sense of what is in the request, besides even trying to know who or from where the request is coming from. VPN applications, if when you install them in your computer, they are always running in the background, so you don't have to do anything extra to be able to use it. So like I was saying, if most websites trying to, they also, after that, the websites that you try to connect to would not be able to track or keep track of your real IP address, because they would only see the VPN address. or anonymous IP address given to you by the VPN. So you can see in the diagram also a request leaving the laptop first goes through the VPN, goes through the VPN where it is encrypted, and then through the VPN server also a new IP address is attached. The request is now sent to the internet as if it's coming from the VPN server with a different IP address from what was on your laptop to the internet. So this is also one of the roles played by VPN to protect you or to keep you anonymous in the internet, or to keep your data safe from hackers, hackers who are trying to intercept your communication. So thank you. Yeah, that's where we come to the end of this first part of our networking topic. Maybe probably next week, we'll go into how networking applies within the AWS framework. So if you have more questions, I will be glad to hear them now.
I have a question. I don't know if it's a question, but I just want to share. Maybe you might throw more light on this this thing that I've been witnessing. Our friends or family members, or maybe people would know who are in the Middle East, like Dubai.
Mm-hmm.
Usually, when you are texting, maybe through WhatsApp, it's okay. But when you want to call, they will be like, "Please wait, let me use maybe connect to VPN before I talk to you." And that for that, I understand that maybe in Dubai they're using kind of private network kind of thing that they don't want to connect to the general public. So now, why is it that because data is data, either text or video, so is it that infringement can only happen with audio communication other than text communication?
Or what do you mean? Oh, because for text communication, it's also encrypted by, if you were saying you were sending it by WhatsApp, for example, it's encrypted by WhatsApp before it's being transmitted. And even your video communication is encrypted. I would think that somebody who is trying to say connecting first to VPN might be more or less trying to hide their location, not really trying to encrypt the data. Yeah. Or
no, what they say is that maybe the United Arab Emirates have made it impossible for them to have a direct internet call through WhatsApp due to one reason or the other.
Yeah.
So so I'm asking, my question is that why is it that the government does not block text messages but block video or audio calls? Is there a particular reason for that?
I'm not sure why they choose just to block video calls, but if you're still doubting why the person needs a VPN for video calls or audio calls, is because with VPN you can change the location of your IP location. Could be different. So if he's being blocked from making a call from Saudi Arabia, his VPN could hide his location and say he's from maybe Cameroon or from another country where calls are allowed, and therefore it can be able to talk to you. But about why the government chooses to block only video calls and allow text communication, it's a little maybe just political, not IT-based problem. I would think so.
Yeah, absolutely. I think Theo, you're right. I think if you just check online, I don't really also know why, But if you check online, you'll notice, I see there are different articles talking about the UAE have decided to block those calls because each country has the control over the internet. Like you look, for example, RT is blocked in Europe, but it's still available in Africa. So there is always some control that some governments can do. We can't know why they're doing it. So as your ex says, it's not an IP problem or a technical problem. And then for people who are faced in those situations, they then can try to use things like VPNs, because VPN hide your address. It can make you appear as if you're in America, even if though you're in the UAE. So when they use those kinds of VPNs, they're then able to bypass it, because a VPN, when you connect to a VPN, you can decide to pretend that you're in Africa or a country in Africa, say Cameroon or Nigeria, but when maybe actually you are sitting in Germany. So it's possible. So when you do that, you are able to bypass and some of those blocking mechanisms implemented by or imposed by countries. But there are still also limitations to it or other things that will follow. Yeah. But that's just kind of like, I hope that helps, Napoleon, right? So because you were asking, you are saying that you're able to send text messages, but you are not able to make voice call or video calls, right?
I mean that when you talk with them through text, is it that you cannot use a text message to identify somebody's location?
Oh, no, the government restriction is not about maybe tracking location.
Good. So it's about data transmission, right?
Yes, they're just maybe worried about what more can be transmitted, what videos are capable for that text are not. So and also maybe, as I said, also it could be more political than really a problem of IT, because if you're asking the question like, what can they do with videos that they cannot do with text?
That's more technically more so.
Yeah.
So video, let me see, putting it, how do I put it?
And also remember that text and voice, they use different protocols. They are all data, but one is using what is called voice over IP protocol. Another one is using a complete different protocol. So it's when you block a protocol for voice or a protocol for video, it means that voice and video will not go. So although all of them are data, there are different protocols that control them, right? So you can block one.
Okay.
I hope that helps. Yeah.
Thank you.
Because I heard you say data is data, right? So, but not even though it's text, it can still, all of them follow different protocols or different languages. And if you block one protocol, then it means that, that particular means, let's say voice in this case or video in that case will not be possible. Yeah. Okay. Right, but that's a real life question or example you brought in there. I think just before time runs out, I just want to remind everyone that networking is a very, very broad topic, and it's always a very long one to go through. So if you look in most courses, they don't even always cover the networking basics like we do here. So if you watch this and you feel like this was much, just take a step back and know that you can always take time to capture some of these basics. But the key thing is knowing what an IP address is, knowing what a port number is, understanding what a VPN is, and and some of the things that have been touched on. Because when you have that, when they start talking about networking in AWS cloud, some of these terms will not be quite frightening to you. And there are some video links. I shared a video also that could supplement what you have presented. I'll still share it today. And subnetting was done by one of our members here 3 months ago, Mike, a very excellent video that could help you go deep into subnetting, because you will come to see subnetting will be used in AWS cloud, although there are websites that makes it very easy, but understanding the fundamentals gives you a solid foundation. And we had a 2-hour session on that. I will share that video link, and just take your time sometime and look at it, so that's the advice I can give. If you have a good of this foundation, don't minimize them, because if not, you always realize that you are lacking on something or you are struggling on something. So it's better now to just invest if you invest about 5 to 8 hours in the next weeks to come to just look at these fundamentals, it will be very, very beneficial for you. Yeah. Okay, maybe we have some more questions, I don't know, on chat, or maybe feel free also to come in based on what you have covered today or something that's worrying you as well.
Okay, if we are waiting, while we are waiting, if somebody has a question, we can look at a few questions that I put together. Yeah.
That's okay.
So the first question, can you see my screen? I guess. See. Ban.
Yes, sure.
You can see my screen.
I'm sure others as well. Yeah.
Okay. Oh, revealing the answer already. Which of the following is or are a valid IP address or addresses? We have A, B, C, D, and E. So you have to choose. Maybe if you want, you can send your answer on the chat or say it out loud.
So far I see 3 Bs on chat. Four people said B.
Yes, 4 people. So yes, I guess they are all right. So the first one is wrong because of the minus sign at the beginning. Second one, third one is wrong because of the columns. IP version 4 doesn't use columns. D is wrong because of the 256. The normal can only go up to 255. And E is wrong again because of the double dots. Whenever there's a 0 in IP version 4, we are not, it doesn't mean that we should replace it with dots. Yeah. Okay, which of the following is or are true about IP version 4 addresses?
I see 2 A's.
2 A's. Yeah. Any other opinions? Somebody says E is correct. Okay, one more person, please. E again is supported.
I think A is correct for me because E is similar to A, so I think A.
Okay. Okay, so I just point out the answers now and we see. So A is not correct because bytes are not the same as bits. A byte is made up of 8 bits. So it's not 32 bits, byte is 32 bits. And B is not correct because it's 32 bits and not 128. C, of course, is correct because there are 32 bits and they are grouped into 4 groups of 8 bits, which means 4 bytes. And D is not correct because it's not made up of 4 binary bits. It's made of 4 bytes. And C, of course, is correct because of 32 bits. Okay. Dynamic IP addresses are assigned automatically by a service called Hello, guys. Can I hear some answers?
I'll go for B.
B, somebody says B, somebody says A. Somebody says A again. I'm worried. B. Okay. So it is B. DNS is a domain name service. And B is DHCP, as I said, Dynamic Host Configuration Protocol. C is something I just made up by switching C and H in DHCP. And T is TCP stroke IP. It's not used for assigning IPs. It's more of a communication protocol. Okay. Okay, question 4. Which of the following is or are true about ports? Can I see some answers? Oh. Okay, I will just go ahead. Yes. Okay, so we have a port is identified by a number. That's true. A port would identify a service running on a host machine. That's also true. Some port numbers are dedicated for a specific application. That's also true. A port can be an IP address like this. This is not true. So yeah. Okay. Thank you all. There's a question on the chat from Edwin. If we are given 5 instead of 4 answers, does it mean we have to automatically choose more than one, or that will be indicated in the question? So yes, it will be indicated in the question. Unlike here, where I just wanted you to be able to figure out for yourself whether there are 2 or there's just one answer correct. AWS will usually tell you how many you should choose in the exam. So they will either say select 2 or select 3, or when they don't say, it means select 1. So yeah. Thank you to Edwin. Yeah. Is there any other question, please? We have Prof. Van. We are over the top of the hour.
Yeah, hello, can you hear me?
Yes.
Okay, sorry, I lost connection a bit, but I'm back. You just finished, right?
Yes.
Okay, great. Let me stop the recording.